Hi everyone, in this video we are going to be reviewing the lessons that we did in live class on September 14th. Here is our flashback for today. This takes us back to previously learned content just so we can kind of keep reviewing that. It says, what is the value of this expression when x equals 2/3? So we're going to take that x value and plug it in everywhere we see an x. So this is called substitution. And don't forget, you can use your Desmos graphing calculator if you'd like to simplify this. We can also do it by hand. This little 2 is our exponent, so that means we're going to square it. We're going to write it 2 times. So we do the top times the top and the bottom times the bottom. 2 times 2 is 4. 3 times 3 is 9. And then over here, you can make this look like a fraction by putting it over 1. 3 times 2 is 6, and 1 times 3 is 3. 6 over 3, that's 2. Bring down the -2. Now look at that. 2 minus 2, those go away. And we are left with 4 over 9. And the answer is D. Don't forget, you can plug all of that into your Desmos as well. So let's look at some special cases. These special cases involve numbers in front of the parentheses here. And whenever we see a number in front of the parentheses, we see multiplication right there. And we want to remember to distribute. So we have to do 7 times 2 plus 7 times 5v. We have to distribute to everything on the inside of the parentheses. And I'll just bring this over. That's looking a little better. Now we can just go ahead and do PEMDAS or GEMDAS, right? Multiplication first. 7 times 2 is 14. 7 times 5v is 35v. And then we are going to combine like terms. So we want to get all the v's together and all the numbers together. So let's take this 3v and move it over. We will subtract 3v from both sides. We do that inverse operation. So this is a positive 3. We are going to subtract 3. So we'll bring down 14. 35 minus 3 is 32v. These cancel, right? And bring down 14. Now we want to get the numbers together. We're still combining like terms. So we'll subtract this 14. And you get 32v equals 0. Last step, this is a number times a letter, right? So remember the inverse or the opposite of multiplication is division. We know 0 divided by anything is 0. Don't forget to check it. Let's plug in 0 to our original equation, and we will see if it works out. So 5 times 0 is 0, and you get 7 times 2. 3 times 0 is 0. Bring over the 14. Sure enough, 14 equals 14. 7 times 2 is 14. Yay! All right. I want you to pause this recording and try the second one on your own. It behaves the exact same way. We're going to distribute the -5. So we're going to have -5 times -2 plus -5 times -8m. We'll bring everything else down. Then it just becomes doing the math, right? -5 times -2 is a positive 10. -5 times -8 is a positive 40m. And we want to do the same thing. We want to get the m's together and the numbers together. So let's subtract 5 from both sides. Bring down the 10. 40 minus 5 is 35. That's 0, right? And now let's subtract the 10. $35m equals 0. Divide both sides by 35. This problem is almost identical. And we would check that by plugging in that 0, right? Or whatever you get, we got 0. Everywhere you see that variable, Remember, it's a surefire way to make sure you got the answer. So that's 0. You get -5 times -2 equals 10. Yay! Negative times negative is our positive. So I know I mentioned in our play posit, like we're using the same tools to solve all these problems, but they all look a little different, right? Like these, the first place we need to start is by distributing. So whenever you see a number in front of the parentheses, you want to distribute. Let's try this one. So our goal is to get t by itself. Remember my tree analogy, we can't just go straight for this term. We have to get rid of everything else first. And the first thing we see, this whole thing is a fraction. So the inverse of a fraction, remember, is the reciprocal. We're going to flip it. So we see the 4. You can think of this as 1 over 4, and you just flip it. Or another way to think of this is division. We're dividing by 4, so we want to multiply both sides by 4. Either way works. The beauty of this, check it out. These cancel. 4 over 4 is 1. So you're just left with the numerator. And that's 1 times 4 is 4. This looks like what we're used to, right? We want to get the t by itself. So the opposite of plus 3 is minus 3. And we divide by 5. And it's totally fine to have a fraction. Let's come over here and check it. Excuse me. Okay, you can grab your Desmos and you can work through this, or you can do it by hand, right? 5 and 5, those divide out and you're just left with 1. 1 plus 3 is 4. And 4 divided by 4 is 1. So we got it. All right, let's look at these. So these look similar, right? But this one over here looks a little different because we have the parentheses on the right-hand side. But they function the same. We see parentheses, we see this number in front, so we need to distribute. All right, so do -7 times p plus -7 times -5. And we'll work through this math together. We have -7p. -7 times -5 is a positive 35. And now we're kind of where we were at the last problem, that second line. We want to combine like terms. So we are going to add 7p to both sides. And look at that, -7 plus 7. You end up with 0p. Let's see what happens. All right, then we're going to subtract 36 from both sides. 0p equals -1. So 0p, that's 0, right? Does 0 equal -1? No, never. So whenever you get down to a solution that doesn't make sense like that, we say there is no solution. And when we look at graphing, we'll see that this does not cross the x-axis. So just be careful, double check your math, because we want to make sure we actually do get something that doesn't make sense, and then we say it's no solution. Sometimes you'll see the hashtag at the end of mathematics. Mathematicians proofs, it's another meaning for end or finished. I did not mean for this to be like, a social media hashtag. It's an actual mathematical symbol that we say we are done. All right, let's look at this one. We'll distribute the -2. You can see we have a pattern here, right? A -2 times a -2. Here, I'll write it out. -2 times -2. All right. -2 times -2 is a positive 4. Now we're going to start combining like terms. So we can move the 4 over. The opposite of positive 4 is -4. -3 minus 4 is -7. And now we'll take the 2v over here. I'm sure you can see what's happening. You get 0 equals -7. Is that true? No. That's no solution. All right, let's get the next ones. Dun, 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 very similar. I'm excited to see what happens though. Negative 4 times v plus negative 4 times 3. Oops. There we go. Okey-doke. Negative 4 times 3 is a negative 12. And now we will start combining like terms. So I'm going to, oops, I don't want to do that. Let's add this 12 over. Negative 4v equals, that's 0. Negative 4v. Look at that. If you want, we could down to something like this where it's the same on both sides. This is another special case, and we say that it is all real numbers. That's a symbol for real numbers. All those solutions. We could continue solving if you want, and we would add 4 to both sides, and you would get 0 equals 0, right? Which is true. And if you look at the graph of this function, it's super interesting. Let's look at that together. When you're using Desmos, you have to use x as the variable. I know that we don't have x, but I'm just going to replace that v with an x. And everything has to be on the same side. So I'm going to move the 12 over and the 4x. We'll talk about this more when we get to graphing. But I just wanted you to see, look at this line. It's a horizontal line right here. And it goes through all the values on the x-axis. And the values on the x-axis are the solutions. So that's just really interesting to see what the graph looks like. It's a horizontal line. Look at this one. We'll distribute our 5 like we have been. 5 times n plus 5 times 2. Okay, we'll combine like terms over here. This is 10. 10 minus 7 is 3. And look, we're left with the same thing. The exact same thing on the left equals what's on the right. Let's continue getting this down to what we might think, right? And these both cancel, so you get 0. So 3 equals 3. Like, yep. And even if you wanted to bring these on both sides, you would get 0 equals 0. So this is all real numbers. That horizontal line. Meaning you could put any number in for n and it would balance on the left and the right. Okay, let's do this one together. We are going to approach it the exact same way, even though it looks really long and there are some fractions. That's okay. We're going to distribute the 7/8 to everything inside. 7/8 times negative 32. Be really careful with your negatives here. 7/8 times negative 48x plus 36 equals, we'll do the same thing with the 2/3. 2/3 times negative 33x plus 2/3 times negative 18 minus 10x. All right. So we can totally use our decimals if we want and type 7/8 times negative 32. Let's just see what that is. 7/8 times negative 32. You get negative 28. Or you can do it old school way, right? And say, oh, 8 goes into 8 once. 8 goes into 32 4 times. Look at that. 7 times 4 is negative 28. Two ways. Let's do 7/8 times negative 48. Get negative 42x. I might do this. There we go. Negative 42x. Bring down the 36. Now, 2/3 times negative 33. 2/3 times negative 33, you get negative 22x. And then we have 2/3 times negative 18. You get negative 12. And we'll bring down the negative 10x. Okay, we've gotten our distribution done and our fractions out of the way. Now we can start collecting like terms. So negative 28 plus 36. That is a positive 8. We'll bring down the negative 42. Negative 22x minus 10x is a negative 32x, and bring down the negative 12. It's just getting smaller and smaller. Let's move the x's to the left-hand side. This is a minus 32, so we'll add 32. And we'll get 8 minus 10x equals negative 12. And then we'll take the 8 over by doing the opposite and subtracting. Negative 10x equals negative 20. Almost done. Divide both sides by negative 10. You get x equals a positive 2. Wow. All of that to get x equals 2. Okay, now let's go to Desmos and check it. So we can do the left-hand side. Just carefully, we're going to type whatever's on the left, and we're going to plug in a 2 everywhere we see an x. So I'll put a 2 here, and then plus 36. So that's our left-hand side. Now let's look at the right-hand side. 2 divided by 3, negative 33 times 2, minus 18, minus 10 times 2. Phew! They match, right? Negative 76 and negative 76. So we are good. Awesome job. All right, a quick sneak peek at our quadratics. So it's called a quadratic because, this is funny because you think of quad and you might think of 4, but quadratics have a squared term. And they look like this, either like that, or like that, or like that, or like that. We're going to do a lot of these this year. And so how might you solve something like this? The goal is still the same, to get x by itself. So we'll subtract 4 from both sides. We get x squared equals 16. Now something we talked about in our PlayPosit at the beginning of this week is the inverse of squaring. So how do we get rid of the little 2? And to do that, you take the square root of both sides. Those are inverses of each other. These cancel out. So you just get x. And the square root of 16 is, well, most of us would say 4, right? But what about negative 4? You may not have really seen it like this or been taught it like this because you don't learn about quadratics until algebra. But whenever you have a squared, there are always 2 possible solutions, the positive and the negative. And that's because, well, look, we can plug it in. If we put in 4 squared, is that 16? 4 times 4 is 16. Yep, 4 times 4 is 16. All right, well, what if we plug in a negative 4? Is that 16? That means negative 4 times negative 4. And a negative times a negative is a positive 16. So that's why whenever you have a squared, you get a positive and a negative solution. So check out this graph. This is the graph of what we just saw of x squared plus 4 equals 20. You could plug this into your Desmos and you would see the same thing. And look, there's our solutions that we got, positive and negative 4. And it's where the graph is crossing the x-axis. That's really important as we move forward in algebra. We're going to see this a lot more. So the solutions of a quadratic equation are where it crosses the x-axis. And it might cross once, twice, crosses the x-axis. All right, we are going to stop here because I want to do our breakout room activity together in class. So thanks for catching up with this quick recording. Please reach out if you have any questions. Bye, everyone.